All right, so JavaScript, like Python. So Python kind of has three layers to it. There's the core Python stuff, and then there's the standard library, right? So if you want to use regular expressions in Python, you have to import RE. So you import that from the standard library, and then you can use it. So it's not part of the core Python language, but it's still in there. And then the third layer, the outermost layer, is just third-party modules, which you can download and then import and use in your code. So JavaScript doesn't really follow that model, but there's something similar where there's kind of a core JavaScript or JavaScript proper, and then there's so because JavaScript runs in the browser, it needs to do browsery things, and there's lots of different browser makers, and they all kind of do their own thing or have their own variations. And so when you run JavaScript in the browser, there's core JavaScript, but then there are all these what are called web APIs, or basically interfaces or ways of interacting with the browser. So you have core JavaScript, and then you have things like, oh, I want to create an alert or like a pop-up window. So JavaScript itself doesn't really do that, but when you run JavaScript in the browser, JavaScript has access to this web API, and it can do things like that. And then there's Node, which is another environment that JavaScript can run in, and Node has its own kind of equivalent API. So there's a whole set of things you can do when you run JavaScript in Node, and most of it is similar to what you can do in the browser, but there are some differences. So we're going to look at one of those differences real quick. All right. So there are, if you look up web APIs in the Mozilla documentation, you'll see a whole bunch of different things. One of them, so I want to focus on promises. So in order to do that, we're going to talk about something that's similar, which is setTimeout. So I can do like setTimeout. So this is a function that exists. It's not really part of the core JavaScript, but we can see setTimeout, and setTimeout will take a callback function. Has anyone ever used setTimeout before?
I think I have, just for like testing something.
Okay, cool. Yeah, so setTimeout, it takes two parameters. One is a callback function, and we'll do something here. And the second parameter is basically the time in milliseconds that you want to delay. So we'll talk about this in some more detail. It's not entirely, it's not exactly wait 2000 milliseconds, but it's effectively the same thing. So we have this setTimeout, which will take a callback function and then a delay, and we can execute this. So console.log. We can do something like so I run it, it waits a couple seconds, and then this inner function executes, which runs this console.log. And we have something similar in Python. We can import again third party, or sorry, the standard library, import time. And we can do something like we'll sleep for 2 seconds and then print. So it'll wait a couple seconds and then it prints hello. Okay. So now we'll do something. We're gonna console log. Do the same thing. Okay, so we're gonna console log starting, and then we're gonna have our let's see there. Yeah, so we're gonna console log starting, and then we're gonna have our set timeout, which is gonna wait a couple seconds, and then call this, and we'll call console.log ending. So
Time was in milliseconds.
yes, yeah. This is in milliseconds, and Python it's in seconds. But yeah, so this is 2000 milliseconds. We're not gonna be here all day. Okay, so the question is, what's going to get printed to the screen when I execute this file?
Starting, ending, and then inner function ran.
Okay, so why do you think that?
Because I'm following along, and that's what happened.
Okay, okay, so that's what we'll go ahead and run this then. Okay, so is there something wrong with JavaScript? Maybe there's a bug, or there could be a bug in this code somewhere. Maybe there's a bug in JavaScript somewhere. Does it make sense?
It just kind of interrupted the flow of the program from top to bottom because it's going to pause 2 seconds before it executes that function.
Yeah. So let's go back. Let's go to Python. This is a little different. So I can execute this Python. It goes starting, and then it waits, and then hello, and then ending. So that makes sense to me, right? This seems like I write this code here and it executes in this order, and that, that makes sense. It executes this line, then executes this line and waits, then executes this line, and so on. The JavaScript example, though, doesn't seem to work in quite the same way. Somehow it executes this line, then executes this line, then executes this line.
Because your console log is inside your set timeout function.
It is, yeah.
So it's going to wait. Whereas in Python, there's nothing within the sleep. It's telling it just to wait.
Good.
And then move on.
Yeah.
So it's running in order, but it's taking 2 seconds for the middle one to finish.
Okay.
I understand correctly.
Yeah, because JavaScript runs in the browser and we really don't want to wait for the page to load. If we're waiting on a function to run, it's going to go ahead and load the rest of the page, and then whatever you set it to timeout, it'll load that last. That way we're not waiting for the entire page.
Yeah. So yes. So those are all good points. The difference between, so what's happening in Python is I execute the program, and this is a blocking operation, right? So everything stops. Everything in my script stops while this runs. In this case, set timeout is not blocking. So somehow JavaScript, it's executing this, and then it's executing this, but it's like, it's not stopping everything else. So it's going to execute this and then somehow keep going and execute everything else. And then it's going to come back to this. So it's a little bit strange, but we're going to take a look at how the JavaScript engine works. Are there any questions so far?
I was just going to ask, does it basically create a second call stack and then you flip to this and I see call stack? So I think you're getting there.
Essentially, yes. Yeah. So Python, if you wanted to do something like this, in Python, you would probably use threads or something like that. So you can kind of create multiple parallel processes that can do things at the same time. JavaScript doesn't work that way. JavaScript doesn't have multiple threads. So if you want to do, lots of things at the same time, and you do, because as David mentioned, on a browser, you spend a lot of time. You spend a lot of time waiting for stuff to happen. So the user clicks on something, you want to listen for that event. User clicks on something, you want to make an API call to get some information or to authenticate the user or whatever. And while that request is being made and coming back, you don't want the web page to freeze up. So if JavaScript were blocking, if everything in JavaScript were blocking, every time you did something on a website, it would freeze. You wouldn't be able to scroll, you wouldn't be able to click on anything. So you can imagine trying to use, Twitter or something like that. And for every network request, everything stops while the request is made and comes back. So that would make it basically unusable. So the way JavaScript does this is it will basically pass certain things off. So here's the call stack, which we all know and love in JavaScript. Here's the setTimeout function. So when my code executes, let's say the setTimeout function gets put on the call stack. So setTimeout is now on the call stack, as we would expect. What happens is, because this is a Node API or a web API, same thing basically. JavaScript will say, "Hey, set timeout. You're set timeout. You might take a while. I'm gonna pass you off. Basically." So the set timeout function gets passed off over here to this web API or Node API. And then the Node API will basically call set timeout. So it's going to execute this function. And this function takes a callback. So it's going to execute this function, after whatever we pass in. So 2000 milliseconds. It executes that function after 2000 milliseconds. And then we have this callback, right? Which is kind of the function that we really want to execute. So this callback then gets put on the callback queue. And then there's something called an event loop, which is constant. You can think of it as basically like an infinite while loop or something like that. So it's just constantly running. And what the event loop is doing is it's checking if there's anything on the callback queue that needs to be executed. And it's checking if there's anything on the call stack. So if the call stack is empty and there's something on the callback queue, then it's going to say, okay, I'm going to move you from the callback queue to the call stack because the call stack is empty now. And then the call stack can execute it. So it's a little bit complicated, and you don't really need to understand this, but just so that this makes sense basically. So I call set timeout in my code. The engine passes this off to the Node APIs or the web APIs. The function gets executed, in our case, waiting 2000 milliseconds. It gets executed. This callback then gets put on the callback queue. Meanwhile, the rest of your code is executing. So things are coming on and getting popped off the call stack. And as soon as the call stack is empty, the event loop is going to say, okay, call stack is empty. Is there anything in the callback queue? Yes, I'm going to put you from the callback queue onto the call stack, and then the call stack will execute this callback function. So that's what's happening here. That's why we get this starting And then, so this is the normal, gets put on the call stack, then gets popped off. Then setTimeout gets called, gets put on the call stack, and then gets handed off to the web API, right? And once it gets handed off to the web API, this call stack is now free again. So it can keep executing the rest of the code. So it's not blocking, it's not waiting. So it can execute this, then it sees this, it passes this off, and then it continues executing. So this line of code. Meanwhile, the web API is going to wait, 2000 milliseconds or whatever. Then it's going to execute. It's going to execute this function wait. Then it's going to pass this inner function. It's going to pass this inner function to the callback queue, and then the callback stack. The call stack will be empty because this is already executed at this point. And then the event loop puts that on the call stack and then gets executed. Are there any questions about that?
Can you see the callback queue with the debugger?
I'm not sure. Yeah, let's take a look. Let's see. Yeah, but so you can see here that the web API is being called. I haven't really played around with this in the debugger, but it looks like there's probably a way to access it. So there's some internal stuff that's happening. Yeah. So I haven't really played around with this much in the debugger, but it looks like you can.
I guess I'm a little bit curious about if you had multiple set timeouts, do they run simultaneously, or is the API like a separate queue where they'd be run one after another?
Yeah, so it would get handed off. So if we had two set timeouts, the first one would get put on here, right? It would get handed off here. And then if this were the next line in our code, this would get put here. And then we'd have basically, this would get executed. So we'd then have two of these, and they would get, in order, put on the queue here, and then they would just get put on the call stack and executed again. So they wouldn't get executed simultaneously. They would get executed in order still.
I guess what I was curious is, like, with the timeout part, if you had one that was 2000 milliseconds, one that was 10,000 milliseconds.
Yeah. So
wait for one to expire before the other.
So they will execute, and then the callback function will get put on here. So the one, let's see, we'll do 2000 and 3000. Well, actually, we'll do like this first one, 3000. So assuming that, things aren't very clogged, basically, this should execute first. So inner function 2. So node web API. So we get starting, ending, inner function 2, and then inner function.
Okay.
So starting, ending, inner function 2, it's 2000 milliseconds, and this one waits 3000 milliseconds.
Yeah, it looked like the first one fired and then the next one fired immediately. It's not like the second one waited an additional 2 seconds.
Yes, that is correct. because it's non-blocking, each one is basically the countdown is going to start here. It's going to wait 3,000 milliseconds, and this is, you know, there's like a whatever half a millisecond delay between executing this and executing this. So yeah, the total wait time is going to be roughly the maximum of whatever set timeout you have.
Makes sense. Thanks.
Whereas in Python, because it's blocking, if I had 2 sleeps, then I would add the total wait time would be, you know, this one plus this one. So that's why JavaScript is called a single threaded non-blocking language. At
I
least
got one
the
question.
engines, yeah.
Does the event loop have to wait for the call stack to be empty, or is there a way to prioritize something in the callback queue to fire sooner, or like as soon as it's ready?
That's a good question. I haven't really done anything, but I know that in the Node API, at least, you can access the you can access the event loop, so you can. I think you can actually manipulate that a little bit, but I haven't really done it myself. So I think you can do things like basically on the next cycle of the event loop, execute X.
Gotcha.
So there's a way to access like the next event loop cycle. Okay, so this is the web API. So what happens if I do this now? So I'm gonna console log starting, and I'm gonna call set timeout, but with no delay. So what's gonna get printed now?
I'm assuming that it's gonna go in order this time because there's no delay.
Okay, so starting and then inner function and then ending.
I think it's gonna be the same order as before,
Okay, so why would it be the same order as before?
because it's gonna clear the call stack, which will have ending on it before it hits the, I forget what it's called, callback queue.
All right, so let's execute this and see what happens. So it looks like it runs basically simultaneously, but we get starting, ending, and then the inner function. And even though there's, you know, 0 delay here, it's still gonna go through, it has to go through this whole process. So the first console log gets put on the call stack and then executed. And then this set timeout gets put on the call stack. It gets put on the call stack and handed off to the Node API, which then executes it basically immediately and puts it on the callback queue. But meanwhile, this call stack is empty. So JavaScript is gonna keep executing the rest. So this console log is gonna get put on the call stack and taken off while the callback function is making its way through this process. So there is, you know, even though it's technically, you know, instant, it still has to go through these phases, which means that it's not going to get executed in order. Okay, so this is the web API and set timeout, and I want to talk now about promises, which is similar to this. So has anyone heard of promises, or God forbid actually use them?
Yeah.
Yes.
It's basically it's kind of the syntax you use to call it API and get a response. And kind of handle that response.
Okay, yeah, so a promise is something you would use to make a network request. So it's something that you want in your code, kind of like setTimeout, where I'm executing my JavaScript code and I want to make a request or do something that might take a while. And maybe I'm not sure how long it's going to take, and maybe I'm not even sure if the request is going to be successful or not. So in JavaScript, the newer way of doing this is with promises. The older way would be to use a bunch of callback functions. But the newer way is promises, and a promise basically represents some value in the future. So I'll just kind of show you what a promise looks like. So it's a little complicated, and this is just an initial introduction. So if it doesn't make sense, that's okay. So we'll create a promise. So we'll use the new promise. So here we have a promise, which is not different than the way you'd create an instance of anything else. Now the promise constructor takes a function. So we're going to pass it a function, just like we've seen before. But this function is kind of complicated. So this function will take two parameters, which are kind of typically called resolve and reject. So the constructor for promise takes a function, and that function has two parameters. And these two parameters are actually functions. So we're getting, we're getting kind of deep in, but so this resolve is a built-in function that JavaScript gives you, and this reject is a built-in function that JavaScript gives you. So you don't need to create these, you just need to kind of, you just need to use them.
You can call that anything, right?
Yes, you can call it anything, but it's, the strong convention is to call them resolve and reject. But yes, these are just parameters, so you can call them, you can give them any name you want. And then what you'll do is you'll call either resolve or reject. So we'll just stick with the happy case first. So this would be, so what you would do here is inside the promise, you would make a network request or something, which could take a while. And then if the response comes back and it's good, then that would be the successful case. And you could resolve, you would call resolve with whatever value you got from making that network request or reading from the file or whatever. Now the question is, because this promise is something that could take a while, you don't want everything else to stop, right? So you want JavaScript to keep running stuff. So the web page, you can still scroll on the web page, you can still click on things, you can still do whatever. Let's do. So the question is, like, what do you do with this value? So I can execute this, and I'm not really doing any work here, so it's going to execute basically immediately. But I could try. So starting, in promise, ending. So that kind of makes sense, right? But what if I want to actually use this value somewhere? Well, you might think you could do something like my promise We'll see what that looks like. This one. And what we have here when we console log is the actual promise. So a promise is actually just an object, and it's, you know, it's got its own internal machinery, which you don't really need to worry about. But the issue is that we can't use this directly. So I can't do my promise plus so if we try to, you know, even though success is a string, this is kind of like returning a string basically. We can't really use that string directly.
You do dot then, my promise dot then.
Yeah. So the way you use a promise is that you have to chain some other methods onto it. So a promise is almost, you can think of it as running, just like setTimeout, it's kind of running in parallel. It almost creates like another process that's running in parallel. Actually, we go back to the previous example. Okay. So here's the original setTimeout example. And if I wanted to, for example, I have, you know, I'm assigning this variable, I'm assigning this value 3 to this variable x, and I can so this will work. So starting console log 3, and then ending, and then the inner function ran. So that's fine. If I change the value inside the setTimeout, so x equals 4. So now x equals 4. So I assign x equals 3, and then I have the setTimeout, and I assign x to 4, and then I'm going to console log x. Well, x is still 3 here. X is still 3 because this hasn't run yet. So you can't really like use, you can't directly use whatever you get here in the rest of your code because it won't be available, basically. So there's something similar with promises, where if I get this value inside of a promise, I can't just use it in the rest of my code because, you know, the rest of my code will have already executed probably by the time this promise returns. So I have to stay within the promise in order to use the code. And you do that, there's some methods that allow you to basically continue processing this thing. And use my promise dot then. So there are basically two methods. There's dot then and dot catch. And you can chain these together. So this will basically create the value that you want. So it's going to do something which might take a while and might not be successful. And then, so that should produce some kind of value. And then when you want to use that value, you call this dot then and dot catch. And both of these will take callback functions. So this will be so this will take a callback function, this is dot then. In this case, I'm just going to console log result, which is going to be whatever I pass in to this resolve. So resolve is the success path, and this dot then is the success path for consuming. And the catch is the consumer for the failure, for the reject path. So it'll probably be some kind of error, but in this case, kind of pretend it's the same thing. So if I did reject, well, first off, we'll do this. Okay, so we get starting, ending, and success. Notice that the order is different, right? So it's similar to the set timeout because this promise is going to kind of go through its own, it's going to go through its own phase, which kind of exists in parallel. So you can think of code, especially I tend to think of code as basically being three-dimensional. And this is more true when you get more complicated code bases, but even though we write it on a two-dimensional file, you know, in a two-dimensional, you know, it looks like a two-dimensional file, it's really, you can think of it as layers of stuff happening. In this case, the promise is basically, you know, it's now in a different dimension. It's kind of running parallel to the rest of what's in this file. So you get starting, ending, success. And if there's an error, so that should be. So if the promise is rejected, let's say we're making it a network request and the user is unauthorized or whatever, something happens and we don't get the value that we expect, we can call this failure path, and then this stop catch is going to handle that failure. Okay, so that's basically what a promise is, and as you can see, promises are a little, you know, maybe not the most user-friendly thing. So more recently, there's basically been some sugar that's added to my promise, some syntactic sugar to make it a little easier to use. So you can do the same thing. We can write a, actually, let me write this as a function. And I'm just going to return this. So I have a function, I'm going to return a promise, and then I'm going to call the, so this should work the same way. It does not. Get promise. This works the same way. I'm just, you know, writing a function that's going to return this promise, and then I call the function. So basically the same thing. Okay, so I have this function, and now what I'm going to do is I'm going to write the same thing, but I'm going to use the newer syntax. So it'll look a little bit different. So what you do basically, if you want to return a promise, you can just add this async keyword, and it will automatically make whatever you do return a promise. So you can do something like this still. And then if I want to consume it, I can do, I'll have to, let me actually, I'm going to keep this the same. And I'm going to do, so I'm going to still use the same get promise, which is going to just return a promise. And then to consume it, rather than using this, you know, .then .catch thing, I'm going to use the async await syntax. So this will be This will be whatever gets returned from the promise. So await. And then here I can comment this out. And I'm going to call this so I got this huge error, which you'll see. And the reason is because this promise, right now it's returning a failure. So it's returning a reject, which means you have to handle it. And I'm not handling it right now. So we're not going to worry about that for the moment, but make this successful. So starting, ending, and success. So you can either use the this chaining .then whatever. So we have a promise, we can chain it with .then, or we can use the async await. So the consumer function will be marked as async, which basically is telling JavaScript, hey, this is going to be a promise. So it's still in the promise universe, just like this is. And then we'll await this promise. So we can write asynchronous code, as though it's synchronous. So it'll await this get promise, and this get promise is basically going to return this result. So success here. And then you can do stuff with it inside this function. You
So if
still,
this was-
yeah, go ahead.
If this was an actual network request, so you would have like a series of conditionals and you'd have like a happy path and a sad path,
Yeah,
like a,
yeah. Let's go ahead and we'll make it slightly more realistic. So I'm going to comment this out for now. Okay, so we're gonna have, let's do a random random number. Let's call this unknown work. And this is basically going to represent so this is going to represent like a network request or something like that. So it might take a while. We're not sure if it's going to come back, if it's going to be successful or not. So this is, we'll say there's a 50-50 chance that it's successful or a failure. So we can do a check. So if unknown work, that is 1, and then we'll do a success. Else. So now we can run this. Good. So I'm going to get rid of the console logs here. I think we got the point. We'll see this is a success, that's a failure, success, success, failure, and so on. So this is random, and we're going to handle, so if our notional network request is successful, we'll hit the resolve, and if it's a failure, then we'll hit the reject. And then when we consume the promise, the success handler is the .then, and the failure handler is the .catch.
What's the point of consuming it? is just that one function at the top good enough, or is that consume optional?
Yeah, the thing is, you can do this, but you can't, you can't really do anything with the value. So you can have this promise, but you can't really use the promise anywhere. So yeah, you can make the network request, but if you actually want to do something with the value, then you need to consume it and handle whether it's a success or a failure.
So if you ran that using the async function you have down there, what
Yeah.
would the console log be for the my value? Would that be the success and failure?
Yeah, it should be the same, except that you have to handle the failure differently. So
Right, but you have a console log statement in that function. What would that what would get logged?
so I just ran it, and when it's a success, it'll do this. We'll see what happens when it's a failure. So when it's a failure, you get this unhandled promise rejection warning.
Okay, so what the console logs returning is what you got printed up there in the resolve or reject the actual.
Yeah, so it's the same thing. I'll move this. So the way you have to handle this is with a try. So now I'm handling. So if you use async await, you have to use try catch. If you're using the dot then, basically you use the dot catch.
Okay, so in that case, it's returning the it's not showing the error because the catch gets it and it's handling it with printing there was an error. Is that correct?
Yeah, you should be able to do this. So we're getting that the failure here. Does that make sense?
Yeah, I think so.
Yeah, so this stuff is, if you haven't seen this before, it's not the kind of thing where you understand immediately. So think of this as the first exposure.
One last question. Okay,
Yep.
the primers will be ran at the top of the program, and then if we would do the consumption, basically to say, okay, so if success, then do this, or if failure, then do that.
Yeah, so this would represent, so we'll see, we'll basically see an example. We'll take a break and then we'll do an example where we will actually, when the user clicks on something, we want to make an actual request to another website to get some information. So this is kind of what that represents. And maybe, maybe the website is down, maybe we're not authenticated, maybe we get back, some information that we think is invalid or bad or whatever. But whatever happens, we want to handle if it's successful, we want to resolve it. If it's bad for whatever reason, we want to reject it. And then we handle this in the rest of somewhere else in our code where we want to do something with that value. In our case, we'll change what's displayed in the web page based on the information we get back.
Okay, gotcha. That's what I thought. Okay.
All right, so let's take, we'll come back at 9, is it? Yeah, in like 10 minutes, and we'll do an example. We'll make a small web application. All right, so we talked about promises. Now we're going to use them. We're going to use something that uses them. So we're going to make a web app, very simple web app. And what we're going to do is we're going to create a normal web page with, here's our starter. So index, we have HTML, we have CSS, and then we'll have JavaScript. And what we want is for someone to go to our website and then click on a drop-down menu, and then they can choose like a base currency, and then they'll get basically exchange rates for a whole bunch of other currencies. So if you want to, see how other currencies are doing against the dollar, you would select, US dollar, and then behind the scenes, we'd make a request to this API, and we'll get back a bunch of information, up-to-date information, and then we'll display that dynamically on the page. So that's the basic idea. In order to do that, we're going to need information about currency exchanges. So how might we get that?
With an API.
Yeah. So API is generally going to be the best way to do this. We could store this information in a database, and then we could run some kind of script or something like a cron job somewhere else that will update our database depending on what's happening. And then we could query our database if you wanted that information. So that's one way of doing it. But if this is, there's a lot of specialization in tech, and if someone else already has a solution, then why not use their solution? So this just happens to be one of the very rare free APIs that don't require a key or anything, so it's good to use for practice. Most APIs are going to have you'll have to supply a key and credentials. So you have to register, and then you get credentials, and then you pay for it, or the first so many calls are free, and then after that there's a charge. So just something to look out for. But there's a good chance, if you want some information, that there's an API out there that will do it. So we're going to use this currency exchange, and the process you're going to go through is the same as, for example, if you wanted to use a new third-party library. You have to read the documentation and figure out how to use it. So we'll click on this exchange rates API, and they have documentation. So API documentation is going to follow typically the same kinds of patterns, and this is called REST. A REST framework, or that's short for representational state transfer. But REST framework is basically how APIs are structured. So you have these different methods. It's just like a database. You can make GET requests here. Probably not going to be able to update or delete or anything like that. But so read, write, create, read, update, and destroy. So GET method. So what does GET do?
Makes a request, network request.
Yeah. So a GET request is basically just like a read operation. So I don't want to modify anything. I just want to get some information. We'll talk more about HTTP requests later. But so we're gonna make a GET request, and here's the base URL /rates. So if we wanted to go, excuse me, if we want to get all the rates, this is what we would do. And that's fine, but we want something a little more specialized. So we want this base rate thing. So rates quoted against the euro by default, blah, blah, blah. So we're going to get all of the currencies, but in relation to whichever currency we specify, which in this example is US dollars. So this is what we're going to get back. So what kind of thing is this?
JSON object.
Yeah. it's JSON. So almost everything that you will get from an API will be JSON. And can anyone tell me about how this is structured? So we have this base URL, and then we have a question mark.
Those are parameters.
Okay. Yeah, so these are called query parameters. So this question mark, and then this is basically a key value pair. So we're going to make a request, and we'll see from, as we later on, we'll actually make APIs, and we'll see how we can handle this. But this is a standard convention. So question mark basically says, and now I'm going to give you some key value pairs, and then those are key equals value. So here we're saying base is USD, and we make a request. That backend server knows how to handle this kind of request. So base, so it's probably going to make a request. So select star from database where, base equals USD. So there's probably some kind of SQL query that looks like that happening on their backend. And then they're going to give us back JSON.
Okay.
So, and then we're going to take that JSON and we're going to basically convert it into HTML and then display that HTML on the page. So we get a user-friendly display. I'm going to start this off. Do you guys, did Tom go over like basically running a web application locally?
Yes.
Okay, cool. So I'm going to use live server.
I think he did open, like
Yeah.
the open.
Yes, you can use open too. So I like, there's an extension. It's not live share, it's
Live server.
yeah. So it's this one, it's very cool and easy to use. It creates a local server, so as you're developing, and it will reload automatically for you. So you don't have to, like, every time you make a change, kind of reopen it. So it's very convenient when you're developing. So I'm running this now. I'm running it on, can anyone tell me what's happening here?
Just running it locally in the browser, not on the internet per se, just using the browser itself locally.
Okay. So does anyone know?
127 is the local loopback address, and then 5500 would be the port number that you're running it on.
Yeah. So here we have this first set of numbers is the IP address, and conventionally local host. So local host or loopback, a couple different names for it, but this just means on this computer. So we're not on the internet. And then there's a colon, and then there's a port number. So in order to, for one computer to talk to another computer, you don't just need the IP address, you also need the port number. So there are something like 65,000, I think, possible ports. Some of them are reserved, but this is basically just an arbitrary one that this program is deciding to use. So we're running on localhost on port 5500. I go there in the browser, and there's basically a process running, or kind of like a local server running on my computer. And when I go to this address, it will take me there. Okay. So I have kind of the base of what I want here. I can take a look. So the index.html is just basic HTML, which I created by doing, this Emmett exclamation mark. So we don't have to waste time doing the boilerplate there. But once I create the boilerplate, I'm going to do a couple things. One, I want to hook up some JavaScript and some CSS. So I'm doing that here with CSS. So I create a link in the head. So the head element here, I create a link and I'm going to call it styles.css. And then here, I'm creating a JavaScript file. I'm connecting a JavaScript file to this HTML through this script tag.
You got an error. You got the file name style instead of styles.
Okay, thank you. So we'll do style. And now you can see that actually changed. So if you look at the styles.css, so the font family that I'm using. So what is this?
HTML tag
HTML.
selector.
CSS select.
Yeah, it's the selector, and what's the difference between, so what kind of element am I selecting?
A block level element.
Yeah.
The entire body of the HTML document, that it's not the head and it's not, it's everything like that, like the parent element. So it selects everything on the page and changes that style for everything.
Right.
Everything in the body tag.
Yes. So here I'm selecting basically this HTML tag. What if I did dot body?
That's a class.
Yeah, so that's a class. So if I wanted to use a class, so I don't actually have a class called body, but I could create that. So I can add this here and I can do something like that. And if I did this, what is hashtag body?
ID.
That's an ID.
Yeah, it's ID. So in that case, it would be ID equals. What's the difference between ID and class?
ID is more specific.
You can only have one.
Yeah. Ideally, you only have one. You only have one thing with the ID of body. It's not, that's not enforced, but the idea is, yeah, you only have one element with a specific ID. Whereas class, you could have lots of elements that have the same class. All right. So this selector, there's nothing special here. You can just look. I mean, you could copy paste. So just search for select. So here's a selector. This is a label, which is just going to give us some text here. And then this is the select element. And the select element has options inside of it. Okay. And then if I wanted to inspect it, do you guys go over using the inspector?
Yes.
Okay. We can use the inspector here. So we've got elements, which is going to give us our HTML. So I can click on different things. There's not a lot going on this page, but this is something that this local web server that I'm running is creating. You can ignore that. And then the console, this will give me access. This is like, I can access variables and stuff that I've created in my JavaScript. And we don't worry about these other ones for right now. Okay, so we've got our HTML and our style and our app.js. So first thing we want to do is I want to get whatever the user has selected. I want to get what the user has selected. I want to make an API call here. I want to get this JSON back, and then I want to display in a bunch of little boxes all of the currencies. So the first thing, how do I grab a value that the user has selected?
If it has an ID on it, you could do get element by ID.
Okay. Yeah, so maybe we should add an ID here. Let's see. And then in my app, how do I get that?
You could assign it to a variable, but it's document.get element by ID, and then put the ID as a argument.
You get element by ID. There's a whole bunch of these, like get element by or whatever. You can also use query selector, which I find more convenient, but yeah, it's all the same. There's a lot of different ways to do the same thing. And because it's an ID, I'm gonna need the hashtag and then, all right, so I'm gonna save this and it will have reloaded. So now I can go here in the console and I can see what that is. So selector, which is that value that I created, shows up here. But so I'm like grabbing this whole element, but I mean, how do I know what the user has selected if they selected US dollars or euros? So what you need here is what's called an event listener. So we can grab this element, but what we really want to do is we want to kind of watch out for anytime someone clicks this, and when they do click it, we want to do something in response. So we're basically gonna write a function. It's gonna attach. It's gonna say, "Hey browser, watch out for this element, and if anything happens to this element, I want you to execute this function that I'm going to give you."
Would you assign that value to the value of select on click?
Yeah. So the basic process here for doing DOM manipulation, you guys talked about DOM manipulation yesterday, right?
A little
bit.
Okay.
So,
Yeah, so you don't have to be an expert, but the basic pattern is I will grab something and then do something with it. So first step, grab whatever you want, in this case that drop down menu, and then we're gonna add an event listener. So selector dot add event listener. And event listener will take a callback function. And this callback function optionally will take the event. So this add event listener is basically gonna check for whatever specific activity. Sorry, it actually takes two parameters. So it's gonna check for whatever specific activity. In this case, there's a change event, but there's a whole bunch of events. Let's see. Let's see if there's yeah. So here's some common ones. This is not exclusive, but on change or change, click, mouse over, mouse out. So basically anything that happens in the browser, you can look for, and then respond to. So here, change. So if the value changes, basically, so if someone clicks on a new thing, then we'll execute a function in response. This callback function, you don't have to, but it'll optionally take an event. So we'll just look at the event first. Okay, so now when I click on this, in the console here, I can see that I get an event. And I click it again, I get another event. So this event object is a huge thing with all kinds of stuff on it. And you can just take a look for satisfy your own curiosity if you want, but we're going to go to the target. And then we're going to scroll way down. There's a whole bunch of stuff on here. I'm going to click some more. And value. So here's the thing that we want. That's going to give us whatever they actually clicked on. So event.target.value. You can see the event.target.value. So, working with the DOM is not, it's not like conceptually difficult necessarily, but you just have to jump through some hoops sometimes. So it's kind of the way it is. It's not always obvious how things work or how you access something. So here I click on this and I get USD. Click here, I get EUR. So now I can, so I've grabbed this element and I've attached an event listener to it. And anytime that event happens, this callback function that I gave it will be executed. Okay, so now the first phase is done. We have access to this value. So what we need to do, looking at this API, I'll copy this here. So I have this thing, and what I need to do is base equals, and then whatever this is. So I'm going to erase this USD. And the question is, well, how do I make this request from inside the code? And the answer is the fetch API. So there's a whole bunch of different, we'll look this up. So the fetch API is a wrapper around some other stuff. So the older thing you would use is XML HTTP request, which is a little more complicated. We can see here's an example. We use fetch and then .then. So what does fetch return?
JSON.
Nope. So if I have a function and then I do .then on it.
Returns a promise.
Yeah. So fetch returns a promise. So fetch is, can be a convenient way of making a request, but it ultimately uses promises. So we can do that here. So fetch, and we'll do base URL plus. Okay, and then this fetch returns a promise. So to use it, I have to chain some stuff together. And so this is a little bit of a quirk, but we'll have to do two .thens to actually get the content. So the first .then will basically check the headers. So this is going to return another promise. Now we'll just console log it. Okay, so we're selecting an element, and then we're going to add an event listener to it. And then based on that value, we're going to make a request somewhere on the internet, and we should get back some JSON. So we clicked on USD, and we got back this JSON. So this is a whole big thing, and I don't really care about, I just care about this stuff. So this rates. So not the whole thing, but dot rates. And here I just get the information that I want. Okay. So I'm gonna actually break this off into a different function here. Okay. So I can do something like this. I can also, so this works, actually, I'm going to call this function here. So one kind of, I guess, downside is that because promises kind of, once you have a promise, you can really only use it within another promise. It creates this pipeline, so you have to chain lots of things together often. So it's very, it can get kind of convoluted. So we're gonna select whatever element we care about. We're gonna say, hey, I want you to tell me anytime there's a change event. And when that event occurs, I want you to call this, to execute this function, which is gonna call this function. This make request function is gonna make a network request, and it's gonna get some JSON back, and then we can do something with that JSON. So I'm actually gonna convert this into, I'm gonna use the async await syntax, because it's a little easier to use, but either works. I'm gonna go async. This is an anonymous function. I'm gonna put async before it. So make request now is an async function. And when I use async, I use await. So so this fetch function is going to return a promise. So I need to mark it as await. And then I can say, and then finally, what I want to do is get the rates. So to mark this as a wait. Okay. Okay, and now I'm going to console. All right. I'll click on something. Let's see, E is not defined. Right. So right here, this function, this would be the Okay, so now I got the same thing. I'm just using, I think, a little bit cleaner syntax, but this is still a promise. This is all still promises under the hood.
What does await mean?
Await means that you expect this to return a promise. So this fetch call is going to return a promise. So you mark it as await, and then you can, it's a way of making this look like regular synchronous JavaScript. So you mark the function as async, and then if you use something that you want to use like later in the function, you mark it with await. So this result, so that I can use the result here on the next line. This also returns a promise, so I have to await that. And then once I have this, my like regular value, I can use it in this function. So I still can't, even though this now looks like regular synchronous code, I can't do something like outside of this rates equals whatever, because that just won't work. So this is, sorry, go ahead.
Okay, no, go ahead. A quick question about your parameters there in the two functions. They're representing the same thing, right? Like you have E in the selector function, and then you have currency down there. They're actually representing the same value, right? The value that you selected from the dropdown.
So this E is the entire event, which is a huge object with lots of stuff on it. And here, so this event is going to, so, I'm saying,
okay, I get you. Okay.
Yeah. So what I'm actually passing in is just, so this event huge object has a target property, and this target property has a value property.
I got you. You're when you call the make request, you're plugging in that value. Okay, I got you.
Yeah, I had when I copy pasted, I had some leftover stuff which I changed here. Okay, so now we're making our request and we're getting all this stuff. So once we have this stuff, we want to create. Basically, I want to turn this JSON object into HTML. So I'm going to get this stuff rather than console logging it. I'm now going to call and notice that basically everything we're doing is side effects now. We're making, so none of these are pure functions. So you could do some stuff to maybe ease that a little bit, but that's basically just how it is. Okay. So we got this convert to HTML. This convert to HTML function. Okay, so we're going to call this, and let's go ahead and take a look at what we have. So rates. So rates is now an object, basically. So I'd like to convert this. Yeah, we'll just do this in an initial phase. So we'll make this a rate string equals JSON stringify rates. Okay, so I'm going to convert this object into a string so that I can easily display it here. And then, so now I have this, but I want to convert this into HTML. So we can do, sorry, once. sorry. So we have the rate string. So what we need to do is dynamically create HTML. Does anyone know how to do that?
Create element.
Okay. So let's create an element. So I'm going to assign this to a variable. We'll create an element and we'll create a div tag first. So we're going to create a div tag. So now we have this element. We've created a new, a new thing, but
Grab the body and append it to it.
okay, so we can append it. But first we want this div to have this content in it.
Could set its inner text or inner HTML to be equal the string that you stringified.
Okay. Dot inner HTML or inner text, I guess. Okay, so I've created a new element and then I basically modified that element. And now I'm going to attach that element to something in a DOM here. I have this already made, so I'm going to use this. So there's the container ID. So if I want to attach this element to this container div, what's the process I have to go through?
You have to retrieve the container through the DOM and then append child.
Exactly. So I have to grab it first. So it's kind of tedious, but document dot query selector, and I think that's a div. So use the hashtag. Okay, so now I want to append this new element that I've created to this container div. So container div dot append child. New element. All right, so let's see if that works. I'm going to select this. And that does work. So I've gone from, now I can monitor whatever the user choose. I make a request to get some information that will be useful to me. And now I'm displaying that information that I got over the network into this page.
A question about inner text.
Yeah.
Does I know inner HTML is kind of insecure because of cross-site scripting. Does inner text have the same problem?
I don't think so. I mean, I've never really used JavaScript in such detail that the distinction has been terribly important, but yeah, I know that there are issues with inner HTML because you're inserting HTML, which means you could be inserting JavaScript tags, which means you could be inserting JavaScript. So in general, I mean, that kind of vulnerability will arise if you're taking user input and then so if we were like, hey, get some user input and then create the inner HTML, you could run a script that way. But
what is the what would be the alternative to inner HTML or inner text? I know there's something else. I can't remember what it is.
You could also potentially just create elements individually and then append them. So
I have a
without
couple
using-
questions about that code right there. So, and you have the new element. Okay, so you created a new div element.
Yeah.
And I,
but it's
I
kind
assume
of
the I,
floating in
the
space.
idea, right, would the ID of that div be new element?
No.
Okay,
No,
because
so
I'm not understanding why we had to create that div, because we're adding it into a div that was already there down on the next lines. So
yes,
why did,
yeah. So I see what you're saying. So yeah, so we can look at the HTML document here. So we have our tag, we have our label. Let me grab this. So now we have this new div which just showed up. Or actually, the container was already there, but inside that container, we now have this other div, which doesn't have
Okay.
an ID or anything.
okay, so we just created another div inside the div that was already there.
Yeah. So what we're going to work up to is we're going to create lots of individual divs for each of these. So that's why we have this outer container. Okay. All right, so we've got now we've got this HTML. So this is not really what we want it to look like, but we've got the basic idea here. So I'm gonna get rid of this for now. And yeah, so the first thing I'm gonna do is I'm gonna convert this rates thing into an array so that I can loop over the array and then create a bunch of individual individual elements. So there are several ways you could handle this. Trees. And then let's do okay. So I'm gonna grab all these and then I'm gonna have a for each loop. And I'm gonna loop over all of these and then create them individually. So rates array for each. Okay, and then in here, what I'm gonna do is kind of go through that same process. So I have selector out here. It would probably be a good idea to make this a class. I'm not going to do that right now, but it's something you would think about doing at this point. So I'm gonna grab this container here and make it available everywhere. All right, so once I have an element, I'm going to go through that process. So I'm going to create a div. So document create element, we'll make it a div, and then div dot inner text, let's say. This is not going to be very pretty, just because I don't want to take too much time going through all these details. But yeah, the internet, and then we'll append this to the container. So append child. All right, let's see what that looks like now. So now we've, basically taken the same thing, but we're just fine tuning our HTML at this point. So we have this container, this big container, and there's a whole bunch of divs inside of it now. So ideally we would break this up, but I'm just gonna keep this as it is right now. Okay.
So what if we look at the if we look at those containers, what would their IDs be? Do they have? Oh, they don't have IDs.
Yeah, they don't have IDs. So in this case, we wouldn't give them IDs probably, but we can give them a class. So we can do that here. So div dot class name equals item, I guess. And now if we do this again, you can look here and we can see that they have this, they all have this item class, which means that we can write some CSS for that now. So let's try and make this a little prettier. So I'm going to use grid. So I want to create a bunch of little cards basically. So the first thing is the container. It's going to do some stuff. And then we also have a class item, and we'll do some stuff there. So this container, just to make it obvious what we're doing, I'm going to add background color of some random color. And here I'm going to do the same thing. So let's just check this out now. Okay. Check this container. Container. Okay, so this container, I want to use grid. So I'm going to do grid. I want, say, 5 columns. Yeah. Okay, so I gotta do something else here. So grid.
So when you make a grid, do you not have to initialize it as display
Yeah,
grid?
thank you. Okay, so this is actually displaying as a grid. I can see that here, it's grid. I can also see these lines here. So I'm getting some help from the browser here. Okay, so now I have these, so these individual elements, I'm gonna make them, let me see, copy this over just to save some time. So I'm just gonna basically make these little boxes. And now I can see that this is getting displayed. So I have a bunch of little boxes, and these are now taking up the whole thing. So change this to template row. Or now it's columns. Okay. So now I'm getting all these things and I'm creating little cards here. There's a couple, we'll make a couple improvements. So one, this container, this outer container, I'm telling it it's going to be a grid. And then there are a few ways of doing this, but this repeat function. So the FR unit, does anyone know what an FR unit is?
One
This
fraction.
is like a fraction.
Yeah. Yeah. So this basically means I want 5, evenly sized elements that are going to take up the whole width. And then each individual item, I'm just basically making it a box. I'm aligning the text in the center. So nothing too spectacular there. I'm going to use a CSS pseudo class. So item hover. When I hover, I'm going to change the background color. See. So what's the problem here? Where's the mistake?
You ain't got the dot.
Yeah. So I'm not telling it the class. So I want it to be the class item. So I have to mark with the dot. And now when I hover over it, it's CSS pseudo class, it changes the CSS when that event happens. Okay. Another thing we could work on is, so this looks good at this width, it still looks fine. And then once we get down to around, what is it, like 900 or so pixels, it starts cutting off. So we can actually change the way that this displays depending on the viewport width. Does anyone know how you do that? Or what?
Media queries.
Yeah, so you use a media query. I'm gonna have to look this up. I don't think Max.
Media only screen and max width, whatever.
Okay. And then here, basically, this is kind of an event. So when the screen gets smaller than 100 or 1,000 pixels, we want to change the layout here. So rather than having 5 elements, we just want to have 1 row. So a single element. So I'm gonna copy this.
I'm not sure if you need only on line 23, like at media only screen.
Yeah, I'm not sure. Yeah, we'll try it. I'm not sure that you do, but we'll see. So I'm gonna change this, and I'm just gonna make it a single column here. You can see that when you change it, so it's over 1,000 pixels. Which you can see up here. It's over 1,000 pixels. It's whatever we want, and then once it hits that, it changes. So if this were on like a mobile device or something, you wouldn't lose information or wouldn't get smashed.
Am I right to understand that if we use Flexbox instead of grid, that would be done automatically?
Yeah, I mean, there's a bunch of different ways of doing it or kind of doing it. They all have their own pluses and minuses. So
'Cause that's kind of what I took away from the Flexbox presentation, was that it's preferred because it handles that for you automatically or something to that effect.
yeah, I mean, feel free to use whatever you want. I'm not a CSS expert. So yeah. But here's some, basic stuff you can do. So we've turned kind of nothing. So basically our entire website is now based on information that we're getting from somewhere else, and it's dynamically created using JavaScript. And obviously you could go into a lot more detail here, but that's a basic idea. Are there any questions about promises or DOM manipulation? Okay. Well, yeah, I think that'll be good for today then. I'll stop the recording.